Hello students and welcome to the lesson on trig functions of acute angles. And to begin, one of the things that we're going to talk about here is what are these special trigonometric functions, and so it helps to start with some basic definitions. Okay, so one of the things you probably learned already from your geometry class is that if you have an angle theta is some acute angle, then we can make a few definitions for this, and we can say that sine of theta, and this should all be review, sine of theta is the ratio of the opposite side of a right triangle over the hypotenuse. So that means I have a right triangle over here, and this is theta, so that's my reference angle. So this is the opposite side. This is the hypotenuse, and this is the adjacent side, or the side that touches the angle. Okay. You've probably also learned already that cosine of theta is the ratio between the adjacent side to the hypotenuse. So the adjacent side would be the length here divided by the hypotenuse, and that also tangent of theta is the ratio of the opposite side over the adjacent side. And so those are the basic ratios that you should have learned already in your geometry classes. So I'm going to introduce three new ratios today. First is, this is pronounced cosecant. Okay, so this is pronounced cosecant. And that is the ratio that's of the hypotenuse over the opposite side. And you can kind of see it's basically the reciprocal of the sine function. Next, this is the SEC of theta, and this is pronounced secant. So we have cosecant and we have secant, and that's the ratio of the hypotenuse divided by the adjacent side. Okay. And I've written this next to the cosine function for a reason, is that you can see that secant is just the reciprocal of cosine. So cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. And finally, the tangent function we have, this is COT. It's not pronounced cot, it's pronounced cotangent. And this is the ratio of the adjacent over the hypotenuse. The adjacent over the hypotenuse, and that's just the reciprocal of the tangent function. And so I can also define these functions, each of the cosecant, secant, and cotangent in terms of sine, cosine, and tangent. So cosecant of theta, if you notice again, it's just the reciprocal. It's kind of like if you took the sine ratio and you flipped it. So we can also define this as 1 over sine of theta. We can also define cosecant as 1 over the cosine of theta, and we can define cotangent as 1 over the tangent of theta. Okay. And sometimes it may be more useful to use the ratio of the triangle. Sometimes it may be useful to use the reciprocal definition. Okay. And we can also say a few more things. Well, since sine is opposite over hypotenuse, then sine is also 1 over cosecant. Cosine is the reciprocal of secant, so it's just 1 over secant. And tangent is the reciprocal of cotangent, so it's just 1 over cotangent. Okay. And there's 6 trig ratios here. There's a lot of ways we can write them. It is possible to try and memorize all of this, but you might find yourself overwhelmed. And so what helps is if you just kind of go back to the basic principles here. You remember from your geometry class the abbreviation SOHCAHTOA. Okay. And that helps you to determine sine, cosine, and tangent. And just think of cosecant, secant, and cotangent as a reciprocal of all of those. Now, one thing that confuses me sometimes is this cosecant actually is the reciprocal of sine, and secant is actually the reciprocal of cosine. So one thing I just keep in mind is that the cos are backwards for sine and cosine. Sine goes with cosecant, cosine goes with secant. Okay. And with that in mind, we're ready to try out and do our first example. So this example asks us that given the secant of theta is equal to 17 over 5, find the remaining 5 trig ratios. And probably the best way to start out with doing this is to draw a picture. And we want to draw a picture of a right triangle. Looks approximately like this. And you want to pick some angle in here to be theta. And secant of theta, so secant back here is hypotenuse over adjacent. So that means 17 here is the hypotenuse, and 5 must be the adjacent side. So the hypotenuse is this length right here, so that's 17. And okay, so this bottom here has to be the adjacent side, and that has to be 5. Okay. And because we're asked to find all 5 of the other ratios, one of the things we're going to have to do is find this missing side here as well. So we'll call this side x, okay? Because that's also going to help us. And we know that 5 squared plus x squared is equal to 17 squared. So that means x squared is equal to 17 squared minus 5 squared. X squared is equal to 289 minus 25. And that is going to give us 264, which is, and then the square root of both sides, x is equal to the square root of 264, and we're going to make sure we simplify that as much as we possibly can, and that comes out to be the 2 times the square root of 66. Okay, so this side here is 2 square root of 66. So now we sort of have all 3 sides figured out, and we can proceed with the problem. Let me write this 66 a little bit neater here. Square root of 66. Okay. And really this is the hardest part of the work here, because once you get the picture all drawn out and figured out, we can basically just use that picture. Okay. So let me start. Since it gives me secant, probably the easiest thing to do here is to find cosine, because cosine and secant are reciprocals of each other. So cosine is adjacent over hypotenuse, so that's just 5/17. Then I can find the, you know what, if I have cosine, let's find the sine next. Sine of theta is opposite, which is 2 square root of 66 over the hypotenuse, which is 17. And in this case, this happens to be in simplest form already, but if it wasn't, make sure that you do a little bit extra work and get it in simplest form. Tangent is opposite over adjacent, so opposite is 2 square root of 66 over the adjacent side, which is 5. And then I need to find the cosecant, and I'm going to write it next to the sine here just so that I help myself remember. Cosecant is just the reciprocal of the sine function. It's the hypotenuse over the opposite, so that's 17 over the opposite, which is 2 square root of 66. Now, see, this is where it's not in simplest radical form because I have a radical here in the denominator, so I have to make sure I rationalize that. Multiply the top and the bottom by square root of 66. And that simplifies to 17 times the square root of 66 over 132. Okay, and that's the final answer. We box all of these answers. And the last one I need to find is the cotangent, which is the reciprocal of the tangent. So that's just 5 over 2 square root of 66. And because I have a radical in the denominator out there, I need to rationalize it. multiply the top and the bottom by the square root of 66. And that will give me 5 square root of 66 over 132. And there you have it. And the main things to remember here is to draw the right triangle first. That's going to be a big help to you. Figure out the other side, and then use the picture to give yourself all of the ratios. And so let me just reiterate that again. So to solve these types of problems, you need to first draw the right triangle. And theta. Fill in values for all sides. And then use that to get the trig ratios. And then use triangle to write ratios. Okay. And just remember that as you do this, make sure you convert it to simplest form, simplest radical form. Okay. All right, so I'm going to stop this video right here and start another video on what happens when we have these special triangles. But the main idea here of this video is that there are 6 trig ratios. You've probably learned 3 of them already in your geometry class. And what we're doing here is just adding 3 more ratios, and it's just the reciprocal of the 3 known ratios already. Okay, and then we did kind of a problem where we were given 1 ratio and we can find the other 5.